glacier is one of the last places on Earth where you expect to see red water. That is why blood falls is so hard to forget. At the edge of Taylor Glacier in Antarctica, a dark red flow emerges from solid ice as if the glacier itself has been stained from within. The image looks wrong immediately, but the real story is not about something supernatural. It is about trapped brine, iron-rich chemistry, and the fact that a glacier can appear completely frozen while still hiding a slow, active system inside. What makes blood falls scientifically interesting is simple. The glacier looks frozen and still from the outside, but inside and beneath it, liquid brine has been able to persist and move. The basic story starts long ago when this area was in contact with seawater. Later, the landscape changed, the glacier advanced, and some of that salty water became trapped. As temperatures dropped, fresh water froze more easily than salt. That left the remaining liquid even saltier. And the saltier it became, the lower its freezing point. That is the key to the whole phenomenon. Ordinary water would freeze solid in this environment. Very salty brine can stay liquid at much lower temperatures. So even in Antarctica, this trapped liquid did not behave like normal water. Part of it stayed fluid, instead of turning completely to ice. That means the glacier could look inactive on the surface, while still containing slow internal movement below. Over time, that brine moved through small cracks and internal pathways in the ice. Not like a fast river, and not like surface meltwater, but as a slow, pressurized seep. When it finally reaches an opening near the edge of the glacier, it emerges into the air. That is when the color becomes visible. The brine contains iron. While it remains hidden below the ice, that iron stays dissolved in the liquid. Once the brine reaches oxygen in the air, the iron oxidizes. Essentially, the same basic process as rust. That reaction helps create the red color that makes blood falls so famous. Researchers also found microbial life in this hidden brine. These microbes can survive in cold, dark, oxygen-poor conditions, which is one reason blood falls has also attracted the attention of astrobiologists. For them, it is a useful natural example of how life might persist in extreme environments far from sunlight. So the red flow is not the mystery in itself. It is evidence. It shows that beneath what appears to be a sealed, frozen glacier, there is still liquid, pressure, and ongoing chemistry. That contrast is what makes blood falls so memorable. The surface suggests complete stillness. The outflow shows that the system is more active than it appears. What looks like a static landscape is actually hiding movement below the surface. Researchers link blood falls to an ancient source of trapped salty water beneath Taylor Glacier, possibly isolated for more than 1 million years. So this is not just a strange stain on the ice. It is a visible sign of a long-lived hidden environment in one of the coldest places on Earth. And that is why blood falls matters. It reminds us that natural surfaces can be misleading. A glacier can look silent and fully frozen, while deep inside it, slow liquid movement and chemical change are still happening. Blood falls turns that hidden process into something we can actually see.